Welcome to Jared's tutorial on bubble sort for C++. This is part of an assignment for Dr. Jackson's C++ class at BRCC. So as you can see, what I've pulled up here is Notepad++, just to talk about bubble sort a little bit. This is the algorithm that's used to do a bubble sort. We haven't done bubble sort in the previous one. Our last assignment was to look at selection, insertion, quicksort, and merge sort. But one thing we didn't cover was bubble sort. And the one that I want to pick this one was because it really sticks out in my mind as being kind of unique and different from the rest, in the fact that the method that the list of numbers or strings, I would probably say numbers, that they get sorted is because the larger numbers get bubbled up to the right and the smaller numbers to the left. So the bubbling effect works because we're dealing with two different loops here. So you have an outer loop and you have an inner loop. And for every loop, your big O value goes up by the one in power. So one loop would be to the power of 1. If you do a loop within a loop, then you're talking about n squared. And if you did another loop on top of that, it would be n to the third power. So every time you add a for loop of any sort, you're increasing the big O value, which is how efficient the algorithm is. This is not the most efficient algorithm out of the ones. I think I have to go look at which one it is, but I think the best sorting algorithm possible has a big O value of n log n. So you'll never catch the worst case scenario where it's always going to be n squared. In this case, it always will be n squared, because even if the list is already sorted, it has to scan through the entire list to check it. So let's take a look at an example list. We have 5, 1, 4, 2, 8. They are not in order. And what this algorithm is going to do is, on its first pass, it's going to run past each number, and it's going to check the first number and the second number, and it says, hey, is this first value larger than the second value? And if it is, it switches places. So I've marked down here the algorithm compares the first two elements and swaps since 5 is greater than 1. And so they swap. And then it's going to go to the next set of values. So it's looking at the 5 and the 4. And you'll notice that the 5 and the 4, since 5 is greater, they swap. Then it looks at the 2 and the 8. I'm sorry, the 5 and the 2. And the 5 and the 2 swap. And then it looks at the 5 and the 8 and it says, okay, 5 and 8 are already in order, and so it does not swap them. Okay, so now you have a list of 1, 4, 2, 5, 8. Still not quite in order, so it does it. This is just in the first pass. This is the swaps it's done. Now it's going to do a second run, and the second run is going to say, hey, 1 and 4 are correct, but then it checks on 4 and 2. It says, okay, that needs to swap. So 4 and 2 swap. Then it checks 4 and 5. That's already correct. It do not swap. And then it checks 5 and 8. That's already in correct order. Those do not swap. Now, on its third pass, you would say, okay, look, the list is already complete. 1, 2, 4, 5, 8. That's a list that's already in order. But the way the loop is going to continue, it's going to continue until there's no swaps necessary. And you notice that in the second pass, we did have one swap. So it has to go through an entire iteration of the loop in which it does not have to swap any values. When that happens, it knows it's at the end, and so it knows that the list is completely sorted, and so it can exit its last for loop. So in the last run, it looks at all the numbers, and the first two values are correct. The second set of values are correct. The third set of values are correct, and 5 and 8 are also correct. So here's your new sorted list. I hope that helps. If you have any comments or questions, please leave them in the comment section below. And thank you for watching.